Hello, happy people. This is Mr. Wilcox coming to you again from my kitchen table. We just finished our logs chapter, and our next chapter is on series and sequences. So, today is the first virtual lesson for Algebra 2 on that chapter. So, we're going to be talking about sequences today. All right, so here's some information about sequences. I'm going to pause for a moment so you can write this down in your notebook. Just pause the video and hit play when you are ready. All right, so a sequence is just a function that's specified by a rule. So those rules get us our next terms in the sequence. Terms are the numbers in the sequence. And so a finite sequence stops and has a limited number of terms, and an infinite sequence continues on end. And usually we call these ellipses. They give those three dots telling us that that is infinite. There are two kinds of sequences. So again, I'm going to pause so you can write this in your notebook. And when you're ready, hit play again. So there are two kinds of sequences. There are arithmetic and geometric. So arithmetic sequences, between each term, we add or subtract something. Remember, adding is just the same. Adding a negative number is the same as subtracting. So if you notice our arithmetic sequence here, we're going up by 4 every time. So we're adding 4 to get to the next term. So that's why that sequence is arithmetic. And geometric sequences, in between each term, we're going to be multiplying. And remember, dividing is just multiplying by a fraction, so multiplying or dividing. So for our geometric sequence here, we have 1 through 9, 27. We are multiplying by 3 every time in between each term, so that is a geometric sequence. All right, so what we're going to be doing today is we are going to be finding the next two terms of any sequence, and we're either going to tell if it's arithmetic, geometric, or neither. So if it doesn't follow the rule of multiplying or adding the same number every time, we're going to put neither. So let's start with our first example here, which is -2, 3, 8, and 13. So in between -2 and 3, it looks like I went up by 5. In between 3 and 8, it looks like I went up by 5. And in between 8 and 13, I went up by 5. So it looks like I'm going up by 5 every time. So my next two terms, 13 plus 5 would be 18. And then 18 plus 5 would be 23. And since we are adding 5 in between each term, this sequence is arithmetic. All right. So for our second example here, we have 1/9, 1/3, 1, and 3. Well, to get from 1/9 to 1/3, I probably didn't, adding would have been harder, so I'm going to try multiplication first. So to get from 1/9 to 1/3, I multiplied by 3. To get from 1/3 to 1, I multiplied by 3. And to get from 1 to 3, I multiplied by 3. If you couldn't see it with the fractions right away, you can always start with your integer terms. So to get from 1 to 3, I would have added 2, but if I subtract 2 from 1, I don't get to 1/3. So the other way I can get from 1 to 3 is to multiply by 3 and then see if that works along the way. So since I'm multiplying by 3, 3 times 3 is 9. 9 times 3 is 27. So there's my next two terms. And since to get to my next term, I'm multiplying by 3, this sequence is geometric. All right. I have a couple more examples for you, and then all right. So our next example is 4, 2, 0, -2, and 4. So it looks like we're going down. So we could multiply by half, but half of 2 is not 0, it's 1. So We could try something else to get from 4 to 2. From 4 to 2, I do subtract 2. And to get from 2 to 0, I subtract 2. And to get from 2 to negative 2, I subtract 2. And to get from negative 2 to negative 4, I subtract 2. So to get to my next term, I'm going to subtract 2 again, get negative 6. And if I subtract 2 again, I get negative 8. So subtracting is the same as adding a negative number. So I'm adding a negative number every time. So I'm adding the same number every time. So this sequence is arithmetic. All right. One last example. I have 1, 1, 2, 3, 5. So to get from 1 to 1, I can multiply by 1. But if I multiply by 1 again, I would still get 1. So it doesn't look like it's geometric. If I go from 1 to 1, I add 0. If I add 0 again, I would stay at 1 again. So it does not look like it's arithmetic either. So let's see what's going on here. I added 0. Here I added 1. To get from 2 to 3, I would add 1. To get from 3 to 5, I would add 2. So it looks like I'm adding the two numbers before it. So to get 2, I took 1 plus 1. To get 3, I took 2 plus 1. To get 5, I took 3 plus 2. So to get my next one, I would take 5 plus 3, which is 8. And to get my next number, I would take 8 plus 5, which is 13. So this sequence is neither arithmetic or geometric. It is actually a very famous sequence or series. It is the Fibonacci sequence or series, which is a very famous series that pops up in nature a lot. So that is what you're going to be doing today. You're going to be finding the next two terms in sequences and telling whether it's arithmetic. Remember, it's arithmetic if you add the same number in between each term. Geometric, multiplying the same number in between each term. And if it's not the same number, adding or subtracting every time or multiplying, then it's neither. You just have to figure out the pattern. So I hope you have a great day. I hope you're happy. I hope you're healthy. And again, have a great day.